Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives, and in this session we are going to discuss this problem involving increasing and decreasing functions, right? So with the help of the concept of derivatives, we'll solve this problem. So let us first read out this problem, and here we have to find the values or the range of this number b, which belongs to the set of real numbers r, for which the function f of x is equal to b times mod of x plus mod of x minus 1, where x belongs to this open interval, that is minus 1 comma 0, is strictly increasing and strictly decreasing, right? So here we have to find out the range of this number b, which belongs to the set of real numbers, for which this function, which is a combination of two mod functions, where x belongs to this interval minus 1 comma 0, we have to find those values of b, or the range of b, for which this function is strictly increasing and strictly decreasing. So here we'll make use of the concept of derivatives to find out the required range of b, for which this function is strictly increasing or strictly decreasing. So let us first quickly see the definition of mod function, because the definition of mod function is going to be very vital while solving this problem. So here we can define a mod of p as positive p whenever p is greater than 0, and mod of p is 0 whenever p is equal to 0, and mod of p is negative p when p is less than 0. And here we are given the function f of x, that is b times mod of x plus mod of x minus 1, where x lies between minus 1 and 0, right? Now see, here we have mod of x. Now mod of x can be defined like this, that is positive x whenever x is greater than 0, and 0 whenever x is equal to 0, and negative x when x is less than 0. Now see, here we have x less than 0, right? And here mod of x is equal to negative x when x is less than 0. So we'll make use of this part of the definition of mod of x in this interval, right? So we can now write b, and here we can write a negative x, because x is less than 0 in this interval. And here mod of x minus 1 can be defined as positive x minus 1 whenever x minus 1 is greater than 0, which implies x is greater than 1, and mod of x minus 1 is 0 whenever x minus 1 is equal to 0. It implies x is equal to 1, and here we have negative x minus 1 whenever x minus 1 is less than 0, and it implies x is less than 1, right? So here in the given interval, we have x greater than minus 1 but less than 0. So x is obviously less than 1, right? So we can take mod of x minus 1 is equal to a negative of x minus 1. It implies minus x plus 1 whenever x is less than 1, and here our value of x lies between minus 1 and 0. So obviously all the values of x which lies between minus 1 and 0 are less than 1. So we'll take this part of the definition of mod of x minus 1, that is minus x plus 1. So here we'll write minus x, and here we have plus 1. So now we can rewrite this function as minus bx, and here we have minus x and plus 1. So now the modified form of this function f of x in this interval is equal to minus bx minus x plus 1, and this is a linear function. So now let us differentiate this function. So here we have f prime of x is equal to the derivative of minus bx minus x plus 1, and the derivative of x is 1. So here we have minus b times 1, and the derivative of x is 1. So here we have 1, and the derivative of 1 is 0. So we have minus b minus 1. So now the derivative of the function f of x is f prime of x, which is minus b minus 1. So the derivative, it depends on the value of b, right? So let us first see the definition of strictly increasing and strictly decreasing. Now see, if we have a function, say y is equal to f of x, which is defined in some domain D, then this function is said to be strictly increasing when we have f prime of x is greater than 0, and this function is said to be strictly decreasing when the derivative is less than 0. So strictly increasing implies that the derivative must be positive, and strictly decreasing implies the derivative must be a negative, right? So here the slope must be positive, that is greater than 0, and here the slope must be negative in case of strictly decreasing, or f prime of x should be less than 0. So now for strictly increasing, we have f prime of x greater than 0. So f prime of x is minus b minus 1 greater than 0. So solving this inequality, we can now write minus b greater than 1, or b is less than minus 1. So multiplying both sides by minus 1, the direction of the inequality get reversed. So here when b is less than minus 1, then this function f of x is strictly increasing. So we can also write b belonging to the interval minus infinity to minus 1, right? And the function is said to be strictly decreasing when f prime of x is less than 0. So the derivative is less than 0. So f prime of x is minus b minus 1 less than 0. Again, solving this inequality, we have minus b less than 1, taking minus 1 to the right hand side and multiplying both sides by negative 1, we have b, and the direction of the inequality get reversed, and here we have minus 1, right? So the function f of x is strictly decreasing when b is greater than minus 1. So we can write here b belonging to the interval that is minus 1 to positive infinity. So this function f of x, whose derivative depends on the value of b, is strictly increasing when b is less than minus 1, and strictly decreasing when b is greater than minus 1.